Okay, number 8. Okay, question from the whole room. What does this mean? What is this really ends up? What is that? Like, you have to start with that thought. Almost every problem we do this entire year, you have to start with this thought. Like, what are you really looking at? Don't just jump in and start doing steps. Like, what are you looking at? What is that, Spencer?
Just a way to find XY pairs.
Okay, raise your hand if you honestly were prepared to say what he said. 3 points, 4 for Spencer. You have to start with that thought. That is a way to find XY pairs. That's its most fundamental reason for existing. Zach, please.
It kind of just looks like it gets simplified in 2 over 1.
Oh, are you thinking? Okay, so ferret kind of looks like that. I totally agree.
It kind of looks like it.
Totally agree. Here's the problem. 3 for Zach. Let's do something similar here. This isn't exactly the same thing, but I think it's kind of what you were thinking. Is that fair? Okay, here's a mistake that is commonly made. Don't do it ever again after today. I really dislike this word because it leads to this type of mistake. People look at that and they go, well, can't I just do this? Like, draw lines through these things, you know? Like, they say, well, that's just 2. That's just 2, so I guess the whole thing's just 0? I mean, people draw lines through them, they cancel, but what's 20 minus 10? Say it. 10. What's 10 minus 5? 5. So it's really 10 over 5, which is equal to 2. I'm having trouble this morning. Yeah, funny. I'll get a ticket for that one. Jared says we should cancel canceling. Yes. Jared. Dang! Another ticket. Yeah, we're into the name tickets now. Caleb said we should cancel canceling, and he is correct. Questions? I don't know if that's your question, Zach. I didn't know if that was your question, really. Kind of. Hey, look. Memorize this. It's really simple. In this class, and I think forever in math, although there are exceptions, don't ever try to divide terms. Sorry, don't ever try to divide terms. You only divide factors. So these are terms. They don't divide. They don't cancel. They don't divide. They don't do anything. They just stay what they are. So everybody good? Okay. With that, we're supposed to analyze what's happening when x gets close to positive a in this case. So we cannot do this. Now keep in mind, we have a formula for finding all the xy pairs. Analyzing continuity near x equal a simply means, imagine that you are making a list and pretend that you can focus on 3 specific xy pairs. Here are the 3 xy pairs you're going to focus on. This is a legitimate xy pair. These 2 are kind of pretending that they really exist. They're not quite real because they're infinitely small, but that's all we're doing. And then the only reason we do these steps is to make it easier to do this. But the purpose of the limit problem, the analysis of the continuity, is to find these 3 values and compare them. The only reason we do these steps down here is so we can find these 3 values more easily. That's all we're doing. Questions? So first thing is it says to factor. So start with the limit. As x approaches a of f. But that is a difficult problem to solve if we don't factor first. In fact, here's another thing to memorize. If you were to take a number close to a, like this one, and you were to plug it into this formula, you're going to get you're going to find that you end up with close to 0 on the top, and you get close to 0 on the bottom. Anytime you end up with close to 0 divided by close to 0, do not say that the answer is 1. And do not say that the answer is undefined or non-existent. When you have close to 0 divided by close to 0, you don't know what you have. It's completely unknown. You don't know what you have. Like, I'm warning you strongly. If you get close to 0 divided by close to 0, you've forgotten something. You've forgotten that, oh yeah, wait a minute. I forgot that if I don't factor, I'm going to mess up the problem. I failed. So that's why we're factoring. If we just go with the formula, we're going to get close to 0 divided by close to 0. It's not going to work. Questions about anything?
See, A is just another variable, right?
A is, it's fair to think of it as a variable. It's better to think of it as an unknown constant, like 6. They just start making you use letters because it makes the math a little harder. That's all they're doing. So we need to factor. I always look for the easy factoring first. You always get 2 lessons in one in my class. So the easy factoring is to pull out a 10. That's going to leave x to the 4th, subtract a to the 4th. On the denominator, I can pull out a 5. Questions? Yeah, please.
Can you factor the numerator further?
You can. You can even factor the denominator further, but the whole point of factoring is always looking for matching factors. So what you need to memorize is, first of all, now that I have factors, I can split up the fractions. So I can say this 10 over 5 can be thought of as its own fraction. Whenever you have a term, subtract a term. They always factor in the following manner. You take the square root of this term, Lincoln. What's the square root of this?
X squared.
Yep, and you write that down. Then you say minus. Lincoln, what's the square root of this term?
A squared.
And then you multiply by what is called the conjugate. Like that. And that's good news because now we found a matching factor. And we can split these into 2 separate fractions as well. And we can put a 1 under that just to make it, so we can see we have 3 separate fractions. 3 more for Lincoln. I'm bothered by anything. Cool. Now you say, okay, if x is close to a, not equal, limit means x is not equal to a. Raise your hand, please. If x is close to a, what is this factor right here going to equal? If x is almost a, hands up. X is almost a, what is that factor going to equal? So in here, let's go. I'm going to call almost everybody. There we go. Taylor, what's that going to equal?
I want to say 0, but I feel like it's 1.
You're on the right. Your thinking is where it needs to be. We just have to tweak it just a tiny bit. If I put in place of this x a value that is almost a, this won't be a squared, but it will be very close. Are you comfortable with that? Subtracting exactly a squared means we won't get 0, but we will get very close. Are you comfortable with that?
Yeah. Are we doing like close to A, like down from A, or a little more than A?
We're kind of doing both at the same time. We're just saying, hey, if it's either a little less than A or a little more,
Okay.
it's still really close to A. So when squared, it's really close to A squared.
Okay.
Sound okay? So this is close to 0. Raise your hand, please. Who knew that this was going to be close to 0? Hands up. Show me. 2 more. 3 for Taylor. Hands up. What's this going to be? Hands up. What's that one going to be? Aisel. Okay, it sounds contradictory. Like what I was trying to warn you about earlier was this. If you get close to 0, divided by close to 0, but you don't really know if they're the same close to 0, then you don't know what you have. The distinct difference here is we get exactly the same close to 0 on the bottom. So that's what Taylor was remembering, I think, is that the entire fraction is not close at all. It's exactly. Like that fraction is exactly 1. 1x is close to a. Okay, 3 for Aisel, 2 for hand was raised. Questions? So what's this going to be? What's this factor's value? Hands up. When x is almost a, what's that going to equal? Just step it out. I mean, just do little bit by little bit. Take away the x. In place of the x, you're putting in a value that is almost a. Then you're adding that to a squared. What is the result? Hands up. There we go. Let's go. Shoot, don't say it. Josh, go ahead. Close. If I put close to a here and squared, this will be really close to a squared. You okay with that, Josh? So I'll have close to a squared added to another exactly a squared. So what I have is 2 of them. So this is getting close to 2 times a squared. 3 for Josh, 2 if your hand was raised. Then we have an extra 2 here. So the whole thing is getting really close to 4a squared. So over here you'd have not exactly, but almost 4a squared. Questions?
If you get 4, I don't think it was
Where's the 2?
Hey, where's the 4? Nightmare. No, you're good. Hey, go here. Liza, help me. Okay, are you okay that the yellow is 1?
Yeah.
Okay, we're going to take away this x, and in place of the x, we're going to imagine that we're putting close to a. That gets squared, so that's going to be close to a squared. This alone will be close to a squared. Okay with that? Then you add it to another exactly a squared. So now you have 2 of them. No worries.
Yeah.
You see it?
Yeah, I do.
So it's really close. It's not exactly 2a squared, but it's really close.
Yeah.
And then that whole thing gets multiplied by another 2. That's a good question. Just keep asking.
there's the
I hope you'll find that I really have endless patience if you're just always digging for the answer. Like digging to understand. Like I really will just keep, you just keep talking. If it doesn't click, we want to keep talking until it clicks. Anybody else? Please.
So then what goes not equal to this because A will go on forever? Oh, wait, where is it?
So what's A is just a number like 5. What we're finding is that if we plugged in close to A, we do get some sort of Y value. And they're very close to each other. But when we plug in exactly A, something different happens. Look, come on, hey, focus. If you put exactly A here, raise your hand, please. What is this right here? Let's get a new color. What's this purple factor going to equal if you plug in exactly A in place of X? Hands up. There we go. What is the purple factor going to equal, Hannah, when you plug in exactly A?
0.
How many agree? 2 points, 3 for Hannah. How about the bottom, Hannah? What will the bottom equal?
0.
Also 0. So we get another subtly different situation. You have 0 divided by 0, which is completely undefined. Undefined multiplied by 2 would still be undefined. Undefined by and multiplied by whatever would still be undefined. So, as is happening a lot on the pink and now yellow packet, we have a removable discontinuity.
And that's because the limit doesn't equal
The
everything.
function's value, yes. So it's always about the 3 values, Ellie. The left and right values here are what find the overall limit for us. Those being equal means we do have an overall limit, but they're not matching the function's value. Yes, please, let's go back to that.
Is that method of factoring by conjugation always valid?
I don't even know what it's called, to be fair. It is, you do end up with a conjugate, like you said, always. And it works in places you wouldn't think it would work, Ellie. Like, you can do this. Not needed much in our class, but I've seen it on a very rare occasion. If I have this, Ellie, it has to be subtracted, otherwise it doesn't work. I can take the square root of the first term, subtract the square root of the second, and then multiply by the conjugate. It always works. It's not clear why that is true, but it is. If you multiply it out, you get the exact same thing. Question on it?
Should you write f of a equals undefined?
You should, absolutely. So here's what my kind of written up answer would look like. Okay, your assignment is to get through the yellow. I will ask if it is complete when I see you on Friday. You do have all the tools you need. It really is just a matter of, again, comparing terms that add when you're doing limits at infinity. If you're not doing limits at infinity, it's mostly factoring is what's usually required. Much of the yellow should feel a lot like the pink. The only addition is you now have an exponential function to deal with and a logarithmic function. So, good job, you guys. Well done. Well done. Wait, oh yeah, please, go ahead.
I still don't understand why it would be
No worries. Are you okay with what we found here? That this limit is the same as this limit. Because all we've done is take what we started with, f, and factored it. Okay, the key is, what I've noticed is, when I look at a problem like this, because I have a lot more experience, I really know where to start from. When students look at a problem like this, they kind of just dive in wherever, and it tends to make it more confusing. So I start right here.
I showered this morning
And I say, wait a minute, it doesn't matter what x I do. This numerator is going to match this denominator. So that will always equal 1 unless the numerator is ever the denominator is also 0. So is there any action you pick that would cause the top and the bottom to both equal 0? Okay. So that's the problem. If I pick x equal a, this becomes undefined. And then undefined multiplied by whatever this is would still be undefined. Undefined multiplied by whatever this is would still be undefined.
So when you were saying 0 over 0 is always
Let's back up. Your questions are perfect. The facts I was trying to get you to kind of just get used to seeing, because they happen over and over again, are if I'm doing some sort of limit analysis and I get close to 0, but I don't really know how close, I just know it's a number that's close. And I find that I'm dividing that by a, wait, calculus isn't math. So, I get close to a different close to 0. So it's not the same.
But because this is the same, it's
Yeah, perfect. So I gotta keep talking about this. Well, no, I want to keep it sorted in the box. I gotta keep talking.
Yes.
So close to 0 divided by different close to 0, we don't know what that is.
Yeah.
That usually means we probably should have factored in just okay.
Yeah.
If we get close to 0
We're just like looking up to
divided by same close to 0, that, what's that going to equal?
Undefined.
That one's 1.
Oh, wait.
That's okay. Like, let it sit until it really feels like you got it.
Close to 0 is the same close to 0.
meaning you get a number that's close to 0, and then you calculate another number and they're exactly the same number. Like neither one is 0, but they're exactly the same.
So close to 0, same close to 0 is x squared minus a.
It's this thing here,
That's the same.
exactly the same, as long as you don't end up with the third case. So there's 3 different things you're kind of looking for that are all really similar but not quite. Such a good question, Clark. The other situation you might encounter is you kind of plug in some stuff and you get exactly 0 divided by, sorry, this is hard to write here, exactly 0. What's that equal to?
That would be undefined.
This is undefined. So there's a big difference. This is, I don't know what it is.
Yeah.
This one is known to be unknown. It sounds weird, but there's a difference. This I don't really know. This one is known to be unknown.
Yeah.
This one here is known to be precisely 1.
So why is this one
Go on.
close to? So the reason it's not 1 is because it's not close to 0. It's exactly 0.
Yes, when we plugged in exactly A.
Yeah.
When we plugged in, so this little box here is going to be either this one or this one.
Yeah.
Problem is
No,
I got more.
If we plug in exactly A,
Problem is like.
this box is this one here.
Yes.
We
that
get
makes sense.
exactly 0 divided by exactly 0, that's exactly undefined. If we plug in close to A, we're finding the limit, this now becomes
So like.
this one.
The
The top is no longer 0, because what we plugged in wasn't exactly A.
Like I'm slipping.
But the bottom is exactly the same thing. So now we get exactly 1.
I understand that. I like can't think of exactly what the formula would look like. I'm not like C1 on this. Is close to 0 over say close to 0.
This one here?
Those one, yeah.
That's what this is.
The song of the film.
I'm doing this right
So that fraction is the same as the close to 0 and exactly 0.
Yeah, let me stop the video and I can